Hello, 7th graders, and tonight we're going to look at lesson 4-3 on prime factorization and greatest common divisor. In tonight's lesson, there are two objectives. First, you will be able to find the prime factorization of a number, and secondly, you will be able to find the greatest common divisor of two or more numbers. So let's go ahead and get started. Alright, so first we need to talk about prime numbers versus composite numbers, because that goes in the first objective tonight. When a number is prime, it means that there's only two positive factors that go into that number. For example, I have the numbers 2, 3, 5, and 7 in there, because the only way you get 2 is doing 1 times 2. The only way to get 3 is to do 1 times 3. The way to get 5, 1 times 5. To get 7, 1 times 7. So there's that number 1 times that number. 2 is not considered a prime number because you could do 1 times 4 or you could do 2 times 2. So that's not a prime number. Now the opposite of a prime number is a composite number, and that's an integer or a number greater than 1 with more than 2 positive factors. And again, 4, 6, 8, 9, 10. So with this 9 in here, you can see it can be odd numbers too. Because to get 9, you could do 1 times 9, or you could do 3 times 3. So here, you need to state whether each number is prime or composite. So we take a look. Well, this goes back to the divisibility rules from 4-1. I know 2 can't go into it because it's an odd number. I know 5 and 10 can't go into it. So then you'll start looking at 3 or 9. Well, 2 plus 3 is 5. Well, 3 and 9 don't go into that. So this one is, not composite, prime. Only 1 times 23 will give you 23. Now, if you can think of any other option, however, it's considered composite. So here we have 45. Well, we could do 1 times 45, or, if you think about it, 5 times 9, that gives me 45. So there are other numbers that work. So this is composite. All right, let's keep moving on. So again, you have to state whether each one is prime or composite. It's your turn now. Go ahead and tell me, is each one prime or composite? And an example, when it says explain, if you can come up with a way or another way to get that number, that's enough of an explanation. So go ahead and do C and D. And when you're all done, come back and check those answers. So pause me now. All right, let's check C. Well, we have 46. Well, going right away, this is an even number. It ends in a 6. So I know 2 times 23 will give me 46. An even number, I know 2 goes into it. So this is composite, not prime. And then we have the number 13. Well, the only way to get that is 1 times 13. So that is prime. All right, so now we're going to look at prime factorization, and it has that word prime in it. So when we do prime factorizations, we take a composite number and we break it down so it's the product of prime numbers. So at the end, all you should have are prime numbers. And the main way we do that, or the way I'm going to show you tonight, is with a factor tree. And I have the one with 40 already started. I have all these blank spots. We just need to fill it in. So I know one way to get 40 is to do 1 times 40. But you don't want to use 1 times 40 in this because then you just keep breaking down the number 40. I'm going to do 2 times 20. All right? Because 2 times 20 gives me 40. Now I take a look. Well, 2 is a prime number, so I can't break down 2 anymore. But I can break down 20. 20 can be broken down in a couple different ways. I think I'm going to do 2 and 10, because 2 times 10 is 20. Now you could have also done 4 and 5 as well, just to let you know. Then we take a look. Well, again, I have a 2, that ends that one, and a 10 can be broken down. 10 can be broken down into 2 times 5. So I take a look. Down at the bottom of my tree, these are my prime factors. 2 times 2 times 5 times 2. Or I'm going to write it so my 2's are all together. I'm using the commutative property. So 2 times 2 times 2 times 5. Now these are the prime factors. However, we just were taught a way to write these too. I'm going to write this as 2 cubed times 5 because we have 2 as a base written 3 times. That's my answer. Now, if you chose to leave it like that, that's okay too. You didn't have to write it as an exponent. I was just using a skill we were just previously taught. So now we're going to do the same idea to this 200. So again, we're going to break it down. And you have to decide what works. Well, I like to always do 2. If I know 2 goes into it, that's where I'm going to start. Because that is a prime number. I can do 2 times 100 gives me 200. Then I can keep going. Well, again, you have plenty of options. There are so many numbers that go into 100. I think I am going to do 4 and 25, just to mess with things a little bit, just to show it. I can do different numbers. Then I take a look. Well, 4 is not a prime number. That's composite. 4 can be broken down into 2 times 2. All right, and then we look at 25. Well, 25 can also be broken down into 5 times 5. So my answer here is 2 times 2 times 2, because I have all these 2's, and then times 5 times 5. That would be my answer. Or again, if I wanted to write with exponents, 2 cubed times 5 squared. All right, so here we're going to do the same thing, and I'm going to let you do this one. Use a factor tree to write the prime factorization of 275. So you know you're going to have 275 up at top, but you need to break it down into prime factors. So go ahead and pause me now. All right, so let's see what we can get here. Well, I know it ends in a 5, so I know 5 itself goes into it. So if 5 times what gives me 275? I'm going to do some work on the side just to make sure I know. And I get 55. 5 times 55 gives me 275. Well, 5 is a prime number, so I'm done there. But 55 I can break down into, again, it ends in a 5, so I know 5 goes into it. So 5 times 11. And I take a look, well, 5 again is a prime number. The only way to get it is to do 1 times 5. And then I have 11. 1 times 11. Well, that's the only way to get it. So my answer here is 5 times 11, or 5 squared times 11. All right. So now we're going to look at the second piece of our lesson today, the greatest common factor, the GCF. All right. It also is known as the GCD, or the greatest common divisor. This is the greatest of the common factors between 2 or more numbers. So when we factor this out, we can find the greatest common factor. All right, so here they say find the GCD of 40 and 60. I'm going to show you one way to do it, and then I'm going to show you another way. All right, I could list all the factors of 40. I know it is 1 and 40, 2 and 20. Well, 3 doesn't go into it, but 4 does, 4 and 10, 5 and 8. There we go. Those are the factors of 40. I could do the same with 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and there you go. So now you can look for numbers they both have in common. Well, they both have 1s, they both have 2s, they both have 4s, they have 5s, they both have 10s, they both have 20s. Now, when they talk about it, the greatest common divisor, they mean what is the biggest number that goes into both of these. And if you take a look, well, they both have 1, 2, 4, 5, 10, and 20. Well, the biggest out of that is 20. So our greatest common divisor here is 20. So this is one way to do it. And I think we talked about this method in 6th grade. Now I'm going to show you a way that uses what we've talked about before. So what you do first, and I have the steps written out in this box over here, all right, that I'm outlining in green. First, you do the prime factorizations. So we're going to factor out 40 and 60 using prime factors. Well, 40, I could do 2 and 20. Then I could do 2 and 10. Then I could do 2 and 5. All right, so 40, if I break it down, I have 2 times 2 times 2 times 5. I could do the same with 60 now. 2 and 30. Then I could do 2 and 15. Then I could do 3 and 5. Those are their prime factors. 2 times 2 times 3 times 5. All right, so that's your first step. Now number 2 says find the common factors. And then 3, it says use the lesser power of the common factors. So here, whatever numbers they both have in common. So here they have the numbers 2 in common, and they have the numbers 5 in common. All right, so they want you to find the common factors. Here it's 2, 2, and 5. All right, so one other way to think about this is any group that matches up. We have a set of 2s, we have another set of 2s, and we have another set of 5s. So they need to have a pair in each one. So here they have a set of 2s in common, they have another set of 2s in common, and they have a 5 in common. If you multiply this out, well, 2 times 2 is 4, times 5 is 20. Again, the GCD or the GCF is 20. So here I showed you 2 different methods. You could write them all out and then find the bigger number, or you could use prime factorizations. All right, so here we have A, and again we're going to do 8. Well, I'm going to let you do A by yourself, and then we're going to do B together because that one has variables. So I want you to find the GCD, or the greatest common divisor, of 24 and 30. And I want you to try to use the prime factorization. So try to use the factor tree and break it down that way. All right? I know I showed you another method, but see if you can make it work using that one method. Because it goes faster, and when you have big numbers, it's hard to write out all the factors of a number. So do A, and then when you're all done, come back and check your answer. So go ahead, pause me now. All right, so let's check A here. I have 24, which is 2 and 12, which can be broken up into 2 and 6, which can be broken up into 2 and 3. So 24, I have 2 times 2 times 2 times 3. All right, and then I can check 30 and do the same. 30, I can be broken down into 2 and 15, and then 3 and 5. So 30, I have 2 times 3 times 5. Right, so now I wrote out their factors. Now I find the common ones. What ones do they share? Well, they share a set of 2s, and they share a set of 3s. All that's left, well, there's no more 2s or 5s to share. So I do 2 times 3, and I get 6. The GCF for A is 6. Now we're going to do B, and we have 36 times A times B squared, and 81 times B. Now, this is going to work the same way, except there's going to be variables involved. But let's break up these numbers first, 36 and 81. Well, 36, I could do 6 times 6, and then I could do, well, each 6 breaks down into 2 times 3. So 36, I can break down into 2 times 2 times 3 times 3. And again, I'm keeping all the same numbers together. I put the 2's together, and I put the 3's together. Now I need to break down this A and B squared. Well, I just have one A, so you'd write times A. But this B squared, again, that really means as an exponent, we have a base of B, but we have 2 of them. So B squared means B times B. All right, now we do the same with 81. Well, I know 9 times 9 gives me 81, and then I break down each 9 into 3 times 3. So for 81, I have 3 times 3 times 3 times 3. Well, on this one, we just have B, which can't be broken down. There we go. So now I wrote each one out. Now I find those common factors again, and I'm going to put them together. Well, they share a set of 3's. They share another set of 3's. There's no 2's they both have. There's no other 3's. But they both each share a B as well. So I'm going to multiply 3 times 3 times B. Those are all the numbers they share. Well, 3 times 3 is 9, and then 9 times B is B. Our answer here is 9B. All right, so that is our lesson for tonight. We looked at the prime factorization and the greatest common divisor of numbers. I will see you tomorrow. Bye-bye.